Hello everybody. In this video, we're going to learn about system of inequalities. So the first question you ask is, what is a system of inequalities? That is when two or more inequalities are taken together. They will either have no solution or an infinite amount of solutions. So you can see down here we have two inequalities. There's the first one and the second one below. So this forms a system of inequalities. Now you might remember that we just did a chapter on systems of equations. Both lines are graphs to find the point of intersection, right? So if we had two lines and we graph them, then the solution is the point where they cross. And sometimes there were infinite solutions, sometimes there were no solution, but there was usually just one solution. So for example, the solution to this particular system of equations is 1, 1. There's only one solution. All right, so when you have the equal sign, that's an equation, and there's usually one solution. Unfortunately, this is not how systems of inequalities work. So when we get rid of the equal sign, some weird stuff happens. Now it's going to be mostly the same with a little bit of twist. So just a reminder here, a systems of inequalities is when you have a less than, greater than or equal to, or less than or equal to. We won't be seeing an equal sign. And they will either have no solution or an infinite amount of solution. We won't look at any cases where there's just a single answer. Okay, first of all, you might be asking yourself, what does a solution to a system of inequalities look like? Well, a solution to a system of inequalities is an x, y point that makes each inequality true. So we're going to do an example. For this system of inequalities, y is less than negative 3 over 2x plus 3, and y is less than or equal to 2 over 7x minus 2. Part A, is 0, 0 a solution? And part B, is 7, negative 10 a solution? So let's start with part A. Here's what we're going to do. We're going to take our first inequality listed, y less than negative 3 over 2x plus 3. Then we're going to take our point as an x-coordinate and a y-coordinate. So we're going to replace the x-coordinate and the y-coordinate with 0 and 0. So this becomes 0 is less than negative 3 over 2 multiplied by 0 plus 3, because x and y were 0. All right, so we get 0 is less than negative 3 over 2 times 0 is still 0. And then 0 plus 3 is still 3, so we have 0 is less than 3. Is this true? It is. So far, so good. Now 0, 0 is not a solution yet because it has to make each inequality true. So that means we also need to check the second one. Y less than or equal to 2 over 7x minus 2. Let's plug in y and x for 0 and 0. So it becomes 0 less than or equal to 2 over 7 times 0 subtract 2. So we get 0 less than or equal to, anything times 0 is still 0, but we still need to subtract 2. 0 minus 2 is negative 2, so we get 0 is less than or equal to negative 2. Now think for a second, is that a true statement? Is 0 less than or equal to negative 2? It is not, because 0 cannot be less than a negative number. So what does this mean for us? It means that 0, 0 is not a solution to the system. And again, it's not a solution because even though it made one of the inequalities true, a solution has to make both of them, each of them true, for it to be an actual solution. Okay, so let's try B. Is 7, negative 10 a solution? It's kind of the same this time, so I'll let you do the work. You tell me, is 7, negative 10 a solution to this system? Try it out. Let's see how you did. X is 7 and y is negative 10. So we replace y with negative 10, and we replace x with 7. Negative 10 less than negative 3 over 2 multiplied by 7. and we add 3. So that's negative 10 less than, when you multiply a fraction and a whole number, you multiply the top of the fraction, and negative 3 times 7 is negative 21 over 2, and then we add 3. Now negative 21 over 2, that is actually, in the calculator, negative 10.5, and negative 10.5 plus 3 is negative 7.5. So is negative 10 less than negative 7.5? And the answer is yes. That doesn't seem right. Well, check out this number line I drew up here. Here's negative 10, and negative 7.5 is here. You can see that this one is bigger because it's further to the right or closer to 0. Another way to think about it, negative 10 is more negative, so it's smaller. Alright, now for the second one. Let's check y less than or equal to 2 over 7x minus 2. Is 7, negative 10 a solution? You tell me. Let's see how you did. So you're going to replace y and x with negative 10 and 7. This is negative 10 less than or equal to 2 over 7 multiplied by x, which is 7, subtract 2. So we get negative 10 less than or equal to, again, multiply the top of the fraction. 2 times 7 is 14, all over 7 times 1, which is just 7, subtract 2. And then negative 10 less than or equal to 2 minus 2. 14 divided by 7 is just 2. So negative 10 is less than or equal to 0. Now you should definitely think that's true because, again, number line, 0 is further to the right than negative 10. So this is definitely true. So this point makes both inequalities true. Our conclusion, 7, negative 10 is a solution to the system. Okay, so next, we're going to learn how do we graph this? How do we find all the solutions? Because in fact, 7, negative 10 is not the only solution. There are more. Here's our last example for the video. We're going to do an example on how to graph the system of equations and shade the solution region. Here's our system of inequalities. It is the same as the previous example. And here are some handy shortcuts which we will be using. So let's go ahead and get started. Let's graph the first inequality with a blue line. You can see that the y-intercept for this is 3. So I'm going to put a dot at 3. And then the slope is negative 3 over 2. That means down 3, right 2. So from that starting value on the y-intercept at 3, you go down 3 over 2, and you can put another point. And you can keep going if you want, but let's just put a few and stop. Next, we look at this symbol, less than. Less than means the points on this line are not solutions. So we're going to graph it with a dashed line. Less than or greater than, you graph them both with a dashed line. Okay, next, where are the solutions? Well, because this is less than or less than or equal to means the solutions are below the line. So they're under it. So we want to shade this side of the line, but not too dark yet, and you'll see why in a second. We just know that the solutions are going to be under the line, under this blue line. Okay, round 2. Let's do the next inequality. Y less than or equal to 2 over 7x minus 2. This has a starting value at negative 2 and a slope of positive 2 over 7. That is up 2 and to the right by 7. So we go up 2 over 7, and we get our line. Shortcuts. This is less than or equal to. Because it's or equal to, the solutions could lie on top of the line. So we are going to make this with a solid line, indicating to everybody that solutions are allowed on top of this line that I'm drawing. Okay, now this is less than or equal to, which means the solution should be under this line. We're going to shade below this line because it's less than. So that tells you where to shade. All right, and now we need to shade our solution region. So we do have 1, 2, 3, 4 different regions, but only in region 4 is where the two shadings overlap. So at the end of the day, everything I'm shading is a solution. Now think about this. In the previous problem, we found a point that was a solution. Let's test it out. We said that 7, negative 10 is a solution to this system. So coming down here, whoops, let's find 7, negative 10. 1, 2, 3, 4, 5, 6, 7. And then negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So sure enough, 7, negative 10 is one of the solutions, and it's in the solution region. So that makes sense. We also found a point that's not a solution. 0, 0 is not a solution. So let's see why that is. So if we find 0, 0, we can see that even though it's under the blue line, it's going to make the blue line true. It's a solution to the blue line. It's not a solution to the green line because it's not under that one either. Another way to think about it, it's not in this nice solution region. Alright, so if I want, I could say that 1, comma, negative 3. There is another solution to this system. Negative 3, comma, negative 18. That's a solution. So here is your final question. Give me one solution to this system of inequalities. You tell me.